Hi, go here to this drawing machine if it might help you at all for teaching or learning. And do let me know if it does, or if you have any questions or problems. Thanks. And now an example. Question 7 is two velocity functions for two particles. Part 1, calculate the value of t at which the two particles have the same velocity. Well, this is a velocity time graph, so we can see we just want to know where the two curves are intersecting, and that's like asking where the velocity function of A gives a value of 9, which is the velocity of B at that point. We don't actually have a velocity function explicitly for A yet, but of course we know that what we are given, the acceleration function, is the derivative of V, the velocity function, which in turn, by the way, is the derivative of displacement function. So when we look in the case of particle B, where what we're given is the acceleration function, so we're down here at this level, we're talking acceleration, we want to go up a level to get the velocity function. When we integrate 0.18t, we do get this plus c, perhaps, but c is 0, we can see, because the initial velocity was 0. So where do these two curves cross? It's where 0.09 t squared equals 9. You cancel the 9s, we're saying it's where 100th of t squared is equal to 1, or t squared equals 100. So t equals 10. And so if we fill in the chart for particle B, we've got the displacement function, and we can differentiate that to get velocity. And then we do know a case in point. An example for the velocity is that u plus 0.24 t squared, we know that's going to be equal to 9 for the particular t value of 5. And then we can see that gives us a u value of 3, because we've got 0.24 times 25, which is like 0.25 of 24, or a quarter of 24, which is 6. So u plus 6 equals 9, and u is 3. And then we can verify, as we're asked to. We can now plug 5 into the displacement function, because we've got a better displacement function now, a more complete statement of the displacement. We know u is 3, so we can say 3t plus 0.08 t cubed. And for the case where t is 5, we're talking about 3t is going to be 15, and then this looks ghastly, but it turns out to be 10, this term here. 0.08 times 125, well, 8 times 125 is 1000, so divide by 100 to get 10, and then we verified as requested. And then finally calculate the velocity of B when t is 16. And we can see the key here is to find out the total distance covered by both particles. In both cases we're talking about the area under the graph. For particle A, what is the area under the graph for particle A? What is the displacement function for A? Here we need to integrate 0.09 t squared, giving 0.03 t cubed, and then we just need to look at the particular case of that where t is 16, because again we had a 0 constant of integration. So we've got the particular case where we're talking 0.03 of the cube of 16. One way or another, you'll get this result of 122.88. Now that's the area under the B curve complete. But notice we also know the area under this part of the curve, because they asked us to find that out, and it was 25. This rectangle here more obviously has an area of 10 times 9, 90. Put them together, we've got 25 plus 90, 115. So how much area is left for this final little trapezium here? The difference between this value, 122.88, and 115, or 7.88. So we know the area of this final little trapezium is 7.88. Let's zoom in on that final trapezium. It's coming from an initial velocity of 9 down to, we don't know, would be nice to find out. But we know, don't we, that the area of the trapezium is 7.88, and we know that the time is a total of 1. But that's rather interesting, because if the area is 7.88, then if the time is 1, this horizontal height, as it were, of the trapezium is 1. We know the mean average of the two bases, even though they're vertical, we'll call them bases of the trapezium. The mean average of the two bases of a trapezium times the height is the area, and in this case it's times 1 is the area. So the mean average of the two bases must be 7.88. So there's the mean average of the two bases, this height here, and we'll call it 7.88. Don't need to worry about the gradient at all, do we? We just need to know the final velocity. Well, it's going to be twice as far down from 9 as this mean average midpoint number is. So it's going to be another 1.2 down from 9, 6.76, and that's the final result. Okay, I hope some of this has helped. Do go to ballooncalculus.org/mechanics if you want to use the software that I've been using here, if it helps for teaching or learning. Thank you.